went on to Armin and Whitney. And my first job with him was taking all calculations and binding them. So I learned a lot about binding, who did what and so forth. He had Jim Chaplin also to do that. He had our group of these guys here to do that. Not to detract from him, but the situation was that this is the way the office was formed. I mean, we had us initiating and putting things together, and we had Lev conceptualizing what these projects were about. I mean, we could get into details, which I know.
But getting to 13, it was Philip Johnson for the New York State and a couple others. Did it just snowball after that because you had a decent number, so they just came to you for the rest, or how did the rest of them all essentially fall into your lap?
It snowballed. I mean, you know, we started to get some small pavilions. I told you how Mexico happened. Spain came simply because the Spanish pavilion had details of welding that were extremely expensive. So we had to Americanize that particular design, right? And that was, came. But what I'm going to tell you is, I mean, once again, you have to understand, everybody considered their project World's Fair, very, very complex, needed creativity and innovation. There was only two guys that could give it in the modern press, and one of them was Zetlin. And I think that once we started to get these jobs, these other people came by and said, will you handle this? Will you handle that? That's the position that I believe is the most accurate.
Zetlin also knew a lot of architects, and they started getting commissions, and the deadline was looming for 64. And so a lot of these architects just dropped these projects right into our lap. I remember the Hawaiian Pavilion. I remember the African Pavilion. My job was to figure out how to keep the fence from being pushed over by an elephant. What happens if the elephant leans on the fence? So I did a little physics, and I designed the fence. It was not a raging bull elephant. It was just a lazy elephant.
Tom, I think the key was when Lev getting the New York State Pavilion with Johnson, and that was the first domino, because once he had that project in the office, these other projects were a lot easier to sell.
Okay, why don't we start diving right into the details of the project? So why don't we start with you, and let's talk about the New York State Pavilion. That was the one that you were focused on, correct?
Yeah, I was at that point focused on the New York State Pavilion, which I see a lot of young faces out there, probably only familiar with it from the Men in Black movies. But the elliptical ring, which was the significantly engineering-wise and innovative part of this whole complex, it was made much more difficult than the Utica bicycle wheel that Lev had done, I don't know, maybe a decade before, because those, as is the travelers, were circles, and of course a circle is just infinite number of identical radii. The ellipse is an infinite number of different radii, so it was an extremely complex thing to solve, and I did it with a lot of help from Jim Chaplin, just using Tomasetti plates and shells, the slide rule. Remember there were no computer formulas in those days. Ken mentioned the fact that Ingalls came up with the idea of building this elliptical ring at grade level and then hoisting it up. One of the features of Dr. Zetlin again was he was an engineering genius and a big concept man, and then he would dump it in our laps to figure out the details. But he was very aware of the details, like the lifting proposal. So this ring was erected at ground level on hoisting mechanisms, and then lifted up into place after the erection was complete, and then what we call needle beams that cantilever out from the 16 towers that hold that seat the bearing of the ring had to be full penetration butt welded. And Lev came to me and insisted that I develop a detail. Once we approved that scheme for erection, he insisted that I come up with a detail to post-tension the tension flange of those cantilever beams, because of his concern for the triaxial state of stresses that would occur after the welding process. So it was that type of thing where he would see that detail and then throw it into our laps.
We've all been in that situation where we do a lot of things so that we can sleep at night, right?
Yeah.
So I can only imagine having a bunch of 22-year-old kids designing.
Exactly.
You're going to go over there and go, post-tension that so I can sleep at night.
He accomplished a lot of our ambition, but through intimidation, quite frankly. Fear.
A couple of interesting points about New York State. The 16 columns you see supporting the elliptical ring, which is about like 320 feet by 240 feet, they were slip formed. Okay, and they were synchronous slip forms, all controlled by jacks, hydraulics, and synchronous stuff in 1962. Okay, when the roof was lifted, it was 16 jacks that lifted this thing. We think we're pretty cool today that we've got these, controls that can control 16 jacks. Well, let me tell you, Ken's company had it all then.
Well, what happened was this. We were a little nervous about this, and I can remember.
Chicken.
Well, I take that back. We had no concerns whatsoever. But I was out there that day, and there was Frank in the middle there, and they started to jack this, and he was in this console. He's like leading the New York Philharmonic.
When they started the jack, I got out from the middle.
Yeah, but he was busy directing this. Well, not like that, but like this, and it went up beautifully. It really did, and it worked well with those cantilevers, the beams that stuck out. We had a lot of welding there, and I'm surprised Lev was not nervous about that.
Tell me more about that. I mean, all of these, I want to get a little bit on all three of these, but these were temporary structures, right? They're all temporary. Yeah. What about your design? What about the construction? Did you do differently because you were thinking they were temporary structures?
I can go ahead.
The only thing that we did differently because they were temporary structures was that I can recall was in the foundations, which were all timber piles. We used untreated piles because this was going to come down in 4 years. But otherwise, the buildings were designed like per code as any other building would have been designed.
Let me just mention about the foundations. My friend Vinny here told me this the other day, and I didn't realize it. For years, what?
No, I'll shoot you with the Vinny thing. Come on.
Vince. Now you made me forget. Oh, so for years I wondered, these were untreated piles, and I knew something about the stratigraphy or below grade stuff, and I was wondering how the hell did those piles stand up for 50 years. I never could figure that out. He told me the other day, and I didn't realize this, that Dr. Zetlin was concerned, and he wound up putting steel piles in it. 9 of them, or 6 of them on each of those foundations. Yeah, steel bearing piles. I didn't even realize that. And he must have done that in the middle of the night and weekends.
3 towers.
Oh, that was only under the 3 towers?
3 towers.
I thought it had to be, because those things this thing would have been in the ground with wood piles. I don't know how.
The 50 years will do to your memory. So, if we blunder along a little bit, you have to forgive us a little bit, okay? But I will tell you anecdotally, because I enjoyed the story. I was there. We were slip forming 4 towers because I loved the engineering, construction. I thought construction was so important. I was out there. We were with a good friend of our firm, a guy named Jack Weber, and Jack used to sell an admixture. And we were there, and they started to slip. Now, if you all know what slip forming is, it's a form that rides up on jacks. You put concrete through the top. It's like a spaghetti machine. You put concrete in the back, and it extrudes it on the bottom. When we got done looking at this concrete from the bottom, we were absolutely shocked. Philip Johnson was coming in the morning. I got to tell you, it was like a funeral. 4 of us looking at this. This was terrible. We started thinking about how to take it down. Well, the concrete's only 14 hours. Yeah, we can take it down, everything else. Johnson pulls up in his limo, looks out, yells, "My God, I couldn't think of anything better. They look like they were thrust up from the earth." Now, the bad problem was how do you get the other 12 to look shitty like that? That was the key. That was the hardest part.
Charlie, you were going to say something?
No, I was just going to. Ken used the word concerned. I've known Ken for a long time. He's always concerned. But Richard Tomasetti and Ken Hiller were in Tehran, Iran, about 6 months before the bottom went out. And Richard looked at Ken, and Ken looked at Richard, and Ken said he was concerned, and Richard said, "No, I'm worried."
The New York State Pavilion. What about the towers, the adjacent towers? Was it that also slip form? How was
the three towers that support the observation decks? That's what they were for, and that's where the men in black rappelled down from. They were also slip form, but they were post tension. The towers, the concrete was post tension to achieve some degree of stability and economies in the reinforcing.
So you weren't post tensioning into the foundations; it was just post tension just for the concrete.
Just for the concrete, yeah.
Okay. So, how much interaction did you have with Philip Johnson during construction, during design? What was that relationship like? Was he in the office? Were you in his office? How was that?
No, we were in his office. We'd attend meetings at his office, and Philip would come out, and he was kind of the Lev Zetlin of architecture. He would come out, and he was a big concept man, very personable, really a nice gentleman, and he would throw out some concepts, what he wanted this to look like, what he wanted that. These, we call them the battle axe. The profile of those, that ring, was his idea, and of course there were many ways to have achieved that compression ring, but he would come out and at his office. I don't ever recall him coming to Zetlin's office, and do the big grand scheme things, and then we'd work with the project architects and those to iron out the details.
Was Lev always there, or did you ever interact with him just as a bunch of kids?
No. If Philip Johnson was going to be there, Lev was there. If it was just a run-of-the-mill project meeting with some of the with the project architects, and Mr. Johnson was not going to be there, then I'd attend by myself.
Sure. 2 points. In those days, in the early 60s, hanging right behind his receptionist desk was the Jasper Johns original of the American flag, and it was worthless. It was not even protected. Now it's probably worth $100 million or whatever. Johnson made that whole school of art, Rothko and all of those people. But the other thing is, Alan's not here, but Alan couldn't figure out the elliptical geometry, or Johnson's office couldn't figure the elliptical geometry. We did it all using logarithms. Mm-hmm. And then later on, he got the job for the tenant fit out in the Lipstick building, which is an ellipse. It was poetic justice.
We had an experience with, I don't think I was hardly ever at Johnson's office except at the end. What happened was we were busy with Frank figuring out how to make the details and all, and finally schedule became a serious matter, so they pulled the curtain down. No more talking, we got to do this. So when we finally saw the thing, we looked at the details, and I got to tell you, as I said before, I think you should all know that the devil is in the details. looking at this thing for 500 feet in the air looked the same, but these details were nightmarish. And I think we told either somebody, we said this is going to cost a lot of money because just the details. So it wound up we had a meeting at Philip Johnson's office. So I now listen, I guess I'm architecturally or artistically challenged, but going to his office, and I don't know about this Jasper, this flag, but I saw leaning against the receptionist's desk, I think it was an Andy Warhol. It was Marilyn Monroe or something with a shade, and I looked at that thing. What the hell is that? It was just a bunch of dirt engineers. I don't know from these things. So then we went into his office, and in his office he had what looked like a huge meteorite in the middle of his office there, and I thought, this is a meteorite. No, that was a work of art. And behind him was a little thing in small cubby holes. Looked like a collection of soldiers or something. No, that was another work of art. So I shut up. We then went back into another conference room, and to get to work, to do the grunt work, to figure out what we're going to do about this. This what we thought was going to be a huge cost. And in there was something that was about 6 feet long and about 3 feet high. I remember it had pink and white stripes. It was a hideous-looking thing, and the end of it was broken off, and there was the mesh reinforcing. And I wondered what is that supposed to be? That was some kind of a sample from some building that they were doing. They'd broken the end of it with a mallet to see if it would hold up. So that's my experience with Mr. Johnson.
All right, we live in a world now where the terrible term VE, value engineering, is out there. Right? You're on a job here where we know ultimately it wasn't a financial success, but I'm sure there must have been some pressure to work somewhere within some budget. Were there budgets? Where were you working?
Oh, of course it was.
And who was the enforcer, and what did you guys have to do to deal with that? Who was driving that?
Of course, well, we did the budgets, of course, and we told people what the budgets were. That's what the problem was. We did budgets as we went along, and then the shade was pulled, and then they finished up the final details when we got to look at them, and we made another estimate. We said, oh, my God.
So did you ever go and make significant changes to the New York State Pavilion in order to get back on budget?
There was no time to make changes. No. So we just built the thing that way.
I think they were all cost plus. Yep. They were all negotiated.
But, well,
there was no budget.
They
just had to get them done. There was no construction manager. It was a GC or a turnkey builder, and that's why it all happened so quickly. The layers of crap didn't exist that exist today.
Yeah, that was partially true, but there were budgets.
If anybody here works for a layer of crap, we apologize, okay?
In those days, even though I worked my final years for a major contractor and construction manager, in those days there was no such thing as a construction manager. The big developers here in New York usually had in-house staffs of a field guy and an office guy, a suit and a guy that went out and worked, and that was it. And they'd hire a contractor and a few consultants, and they'd build these buildings.
Last thing before we move on to one of the other pavilions. What about the materials other than the slip form? What about the cabling? Was this all domestic? Where'd you get this all?
I guess we probably got it from Roebling. I don't remember.
Bethlehem.
Roebling did the cables. Yeah, it was all domestic.
Yeah, you didn't have.
Okay.
Yeah.
Roebling did the cables. Ingalls Iron Works was in Birmingham, Alabama.
Well, yeah, we did most of it.
Because we know, it's been one of the things we lament as engineers and architects in New York is the fact that cable structures in the U.S. in general have become such a challenging thing, and truthfully, to get the material and cables and to utilize them, most of the time you have to go overseas to get them, and that's driven down over the last, whenever we've tried to incorporate them in our projects in the last, as long as I've been around, 35, 40 years, it's almost, the price becomes prohibitive because of the issues you get with. But it seems that clearly wasn't the problem back then.
Yeah, I think the cables on New York State came from Roebling. I know the cables on Travelers came from Bethlehem Steel, Williamsport, Pennsylvania. We were out there. We were watching them make these so Bethlehem, these were the golden days, because Bethlehem and United States Steel, American Bridge, would come into our offices and make everything that we had maybe not done exactly right work. They were fabulous. Guess what happened? They're dinosaurs. They're all out of business.
Tom, just to address your budgeting question again, if I can, there really was no driving us, the designers, to make this essentially an economical structure. You know, it was the architectural grandness, the structural grandness. If you were looking at pure economy, this roof would have never been, you know, the shape of the cables the way they are. They would have been like the Utica Coliseum, where the load-bearing cable is on the bottom. So engineering-wise, it doesn't make sense from an economical standpoint, but from a purely architectural design standpoint, that's what Philip Johnson
Well, I'm sure
wanted.
speed was important, and also these weren't structures you could point to the last one and say it's got to be as efficient as the last one, right? I mean, that was,
right.
You know, we run into that all the time where we are now, where people are always comparing and saying, is it, you know, how many pounds a square foot, and anything that's more than that, regardless of what creativity it might add and drama it might add, tends to be whittled away.
Once we got into the design, you made the concept and the details as economical as possible, but the overall concept was not necessarily driven by economics.
Hey, let's move on, Vince. Let's talk about Kodak. You were saying it essentially it's a moonscape.
Yeah, I mean, it was called the Kodak Moon, and I'm going to use that now to sound off some of the things I wanted to say normally. First off, it's obvious that was done by an advertising firm, okay, so that goes back to what Charlie said. And the second thing is that it was a free-form concrete structure. And now I think I have to go back to one of the elements. All the things we did were analytical. I don't want to like say that it was inferior. I mean, don't forget, before computers, we designed a lot of buildings. I mean, you had a bunch of guys, I mean, all over the world, starting with Luigi Piernervi. You could talk about about Timoshenko. You could look at O'Rourke and all. These books told you analytically how to get very, very close to your number. So we weren't really banging around trying to sort out what ballpark we were in. We more or less knew what base we were on when we got into this. Now, the Kodak show was interesting. Free-form concrete. Well, nobody's ever really done it before. So what we did was to take a look, and once again, I got to say, we were all involved. Like, for instance, I remember Frank Marino in that. He may remember me on the New York State. We all, this little cadre of 5 guys, really tried to help each other out where they could on each of them. But the point I want to make is that when you get to this job, what you did is you had a plaster model on your deck. You went ahead and you had a planimeter, and you rolled it along and you took readings so that you could reproduce every 4 foot a section across the plaster model in both directions. And what was the purpose of that? The purpose was to try to assimilate or approximate a structure. If you look at that corner there, you'll find out that it really resembles an arch. There's a number of things on here, for instance.
Can people see that? It would be helpful if I turn that a little bit over there?
Maybe, yeah.
It's a free-form shell, no mathematical equation.
Correct. It is a Geary shell.
Right.
Right. But basically, you could see geometric forms in there. You could see arches. You could see that the columns are conical, so you've got tremendous rigidity, and these are things you had to play with. I did something silly. I spent 6 months on a thing called column analogy. I really don't even want to go into that. I'm still bored after 50 years. I think it destroyed half my brain. But that was what we had to design with. You take a picture, take it, you rotate the moment of the member about a neutral axis, et cetera, et cetera. Well, to make a long story short, when we did that, there was still a cantilever that it turned out to be that cantilever, I think Frank may be addressing it even better, that cantilever began to go down. We didn't know how far it was going to go. I think it stopped at 13 or 16 inches, but it did stop. But, I mean, this was just part of it. Nobody got nervous about that. Nobody said, oh, my God, your beam came. No, it was a cantilever. It went down. It was 13, 16. That was fine, and it stabilized. But throughout all this thing, I mean, these were being done very quickly. The key here was how do you build? That gets me into the thing you might want to stop me on, Tom. I think one of the things that we had at the World's Fair, which we don't have, we had strong contractor participation. I would even go so far as to say that this was almost design assist. So far to say the guy who did the formwork, when he came up with the formwork, he realized there were certain surfaces we needed to have. We really had no real separation between what they were trying to achieve and what they were trying to achieve with our designs. And I think that was a big plus. We got a lot of things done. I mean, the cheese didn't come to me in a CATIA or a computer thing. The cheese came like a cheese. So how'd you do it? What size are the frames? You gave him the frames, and he went and he warped plywood, and he made a cheese out of it. I mean, there was a lot of that going on. I mean, if you look at the pavilions for the pavilions of the future, as Ken would say, they were really hollow shells. It was the mechanism in them that made them exciting, if you have seen it. But in this particular thing with the Kodak shell, it was the moon surface. We did have some anomalies. We did have a lot of deflection at one point. And once again, nobody killed you for this. We got a delamination in the shell. We actually had a delamination that every time we tapped it to find out where it was, it traveled another 3 feet. So we wind up with approximately 400 square feet that had to be stabilized, chipped out, and then replaced. These things all happened. Nobody sat there with their attorney and said, oh my God, Vince, you know, the towers look like shit, so we're going to sue you. No, the guy liked it, right? That was the key. So, again, so the point I'm really trying to think together is we weren't fools. We like computers, but we really were able to get us on the right base simply by the analysis and the analytical methods that existed before this.
The really fascinating thing about Eastman Kodak was that the model was measured, as Vince said, with Ames dials, planimeters, by a bunch of architectural students, I think, from Pratt. And then we sent the geometry out to a firm in Chicago, and they built a micro-concrete shell, which was probably 10, 15 feet long. They loaded it, they put plastic over it, they vacuum loaded it, and they had strain gauges, linear strain gauges, and strain rosettes, top and bottom. The strain rosettes and the strain gauges were converted into bending moments and shears, and that's how we designed it. It was designed by taking strains off a microconcrete model, converted into moments, and the rebar was laid in tediously by hand.
Well, you talk about tediously. I look at those pictures, and I think that's right. That's that picture over there to the left, right, with the work. But that's laying in the tendons on there. I mean, I look at that and say, I can't imagine any firm in New York, any construction firm in New York, doing that today. So, what was it about the workers that were there? I mean, and when I say they couldn't do it, yeah, we could do it. The dollars would be astronomical. What was the workforce like that was doing this? Were the people working on this? Was this first generation from overseas? What was the workmanship, Ken? What were the kind of people that were working on this?
The iron workers, and they were.
Can you speak into the mic?
Oh, I guess I should. You really want to hear this? Thank you, Vince. The iron workers are a very proficient trade. They really are, and they were, and they are.
But this wasn't standard iron work. I mean, this is what the
it
buildings that were done. Somebody
well,
says, "Hey, I want you to start laying out rebar and pouring concrete and
you
forms."
Understand, these things all are. They start out with elements, and you work from the elements, and you build the thing. And we built it that way. We weren't that familiar with cable work, but there were plenty of people around, bridge builders and so on, that were. We didn't have real problems with the iron workers, and we normally don't today, or the allied trades. They don't work as hard for various reasons I won't go into, but they.
But were you working with the same tools? Is it still rebar drawings? What were they following to?
Number one, there was a giant in the concrete industry in New York City named Roger Corbetta.
Oh, yeah.
And right under Roger Corbetta was George Pavarini, and they built that shell. And I don't know where they found the carpenters, but it was almost like cabinet work.
Shipbuilders.
The form work was better. They should have just left the form work
It was
and
true.
not poured the concrete.
But it was true.
Architecturally, it was more beautiful.
Sure.
It was gorgeous.
They went to shipbuilders for this, from what George Pavarini said. That's the only way. That shipbuilders to develop that form. That was the only way they could do it. So it turned out. But you're right. It was gorgeous. Really beautiful thing. But anyway.
I've had a lot of architects over my career say, why did we put the facade on it? We should have just left it exposed structure. And this was a classic example. It might have burned, but it was beautiful. Thin fir and spruce and all bent and probably steamed. It was a ship. It's like a Viking ship.
So Vincent, did it show up in this form? Did they just come in one day and say, "Here's what we want you to build," or where was the interaction with the designers to get to this form? You said it was more ad than architecture in the sense that they were. Where did the Kodak? Who did you interact with? What did they show up with, and how much did you modify it, or did you say, "Okay, you want us to build that? We'll build that"?
I think that was what we were built. I mean, we given the model. And we did what we could to get it off. And as Charlie says, an exact replica, thin shell, was then load tested. And all that was, if memory serves me, that was with great fidelity. This thing actually at the end, except for minor things, exactly exemplified what the original model was all about. And, and how did it work? It worked like, okay, we knew the best concrete guys, so we brought in Corbetta. We brought in actually the most active of the two, which was George Pavilion. He said, how would you build this shell? Now, that's not pre-stressed. Those are all cables. Right. I mean, all rebars that are just laid because of their size and so forth. And they came up with this scheme. They went to a shipbuilder, and they said, we want to create this form. And, of course, there was a lot of pushback. What are we going to do? How do we do it? And so forth. They really came up with this scheme on their own after realizing that this was the form. There was no abbreviations. We couldn't take it and make it out of a series of straight chords, which one of the guys that did the job wanted to do. They wanted to do it with flat chords, and that was absolutely not acceptable. The surface of the moon does not have flat chords.
So what about the schedule?
At least not my moon, anyway.
I mean, this building had a lot of program inside it, unlike the New York State Pavilion, which obviously didn't have it. It was beautiful, and they had to get the glass in, and they had to get the mosaic done, but there wasn't a lot of program. How did the program? This is a structure that no one's going to be working under until they pull the forms and it stops deflecting. How did you interact with the programmatic, and was it down to the wire or?
Really, the reality is that most of these buildings were down to the wire. There was no room for error to come back and do anything else. I remember, the last few days there were zombies walking around. They were planting hydrangeas and geraniums just to get the place finished. It was a horrible, horrible ending, honestly, guys. As a matter of fact, it was the last week of the World's Fair that created all those Department of Labor charts that tell you that when you work beyond 48 hours, your efficiency goes down, and it goes down. That was created simply by the last month of the World's Fair, with the craziness that was going on, with the guys that were trying to finish, and they were all worn out. They were beat up. When the day opened, you really wanted to go home and sleep for a week.
So did all of you say, hey, I don't even want to go here, I spent so much time working here, or was this a place that Lev was very proud to go and you all went to see your buildings?
We all took the kids.
That's it.
Kids? You were 22 years old. Wait a minute.
We had a lot of kids. We came from a Catholic college.
That's why we work so hard, Tom.
When did you have time for kids?
We were all married and had children.
We all married 3 of us in the same year.
1961, and we all had kids in 62.
On how much a month?
$98.
Okay.
I got 100.
Oh, yeah.
Don't get started now. He didn't know that.
Hey,
he was
how did
running
you
the
get
office,
100?
damn it.
How did you get 100? I only got
100 a week.
But anyway, yeah. So the thing is, towards the end, this thing was vicious. Literally, there were people falling down trying to finish and everything else. To give you a little background anyway, okay, let me give you a little bit more of the atmosphere. The atmosphere is that Nelson Rockefeller was the governor.